Hi everyone, it's me, Chelsea Moose. We're gonna finish up our notes on the unit circle and talk about radians real quick. And so radians are useful. So over here I'm gonna say in your little column, because you have Cornell notes, so like you have radians and you have degrees. And you have other stuff for the unit circle, actually, but right now we're going to go between those. So in your calculator, you might have to switch mode if you are calculating at home in Calc. You later. So just heads up on that. All right, so real quick, vocab. So a radian is something specific. Radian. We see the word rad, R-A-D, a lot in math because it comes from the word for root. It's like radical, radish, right? It's a root. It is. Okay, so a radian is this. It's a unit of angle, not angel, angle, equal to an angle at the center of a circle, and this is the important part, whose arc, ARC, is equal in length to the radius, whose arc is equal in length to the radius. Okay, so this is from geometry. It is. So I'm going to draw a circle. Well, I'm going to try. I have like a circle thing on here, but I'm not very good at using it. So you have a circle. You get the idea, right? That's a unit circle. 0, 1, etc. -1, 0. -1, 0. Oh, crap. I always do that. Well, not always, but I just did it. 0, x is first. Okay. So a radian is really specific, and I'm not going to draw it perfectly, but I'm going to try. It's like here. So this is 1 radian. I know. So I'm going to post a Khan Academy for this. So it cares about the arc. And this is the arc. Okay, the other thing, I'm going to say this in a star. 1 radian, sometimes you'll see just rad. 1 radian is, well, approximately 57.3 degrees. Obviously we're rounding, and so if you had radians, they're actually precise. So let's say something about that. So I'm going to say like using radians, use precise, because we don't have to round, no rounding. So sometimes a question will ask for radians in your answer, and that's why, because it contains the whole answer. For a decimal approximation, you would round. The other thing is that we won't usually calculate out, so we're going to leave pi. When you type it, you're going to write pi, in your solution. And I think in one of the Desmos, it will like calculate it for you. But right now, for our purposes, we don't really care about the decimal approximation. So like, do not need decimal approximation. I'm going to shorthand that. right now. Obviously, if you're an engineer, you'd want that. Okay, so is that all I want to say? Yeah, well, yes, that's all I want to say. So we're going to go to the next page. Bye. We're here with our beautiful, I had to fix it and I think I made it worse. So we are going to, I need my red again. We're going to finish our radians. So we're going to add in radians. So this is like these are the notes you took the other day, or maybe you're doing it all in one day. I don't know what you're doing anymore. The other thing, please remember, please. So our quadrants go 1, 2, 3, 4. I'm gonna do this also 1, because I know in Khan Academy it does this, or not whatever it's called, Desmos. IV is 4 Roman numerals. These are Huggy Boys, so I'm gonna write that over here, Roman numerals. I know for me, I only have to think about that really when it's the Super Bowl, because I use those for some reason. Anyway, sports reference. All right, so okay, I'm gonna try to do this quickly. And I'm wondering why I forgot that other thing, because I want to do some conversions. Okay, so by now, where's my red? Oh my gosh. I am so grateful for your patience, because remember when I told you to write these over here? Those are actually for my radians. This is what first period is like. I always have to deal with my mistakes. So third period, welcome. I appreciate all the grace that you can afford me. Okay, listen. This on the outside for the last time. 0, 1, -1. That didn't really help. Okay, so I'm going to highlight these with, I'm going to go with yellow, because I don't think I've used yellow. So I'm talking, oh, I see the double. Oh my gosh. Okay. Listen, everyone, doing the best I can. All right, so I'm gonna fill in all these little buddies with their radians. So this is what was missing last time. Okay, so for those of us who might already know, if you go all the way around a circle, you end up with 2 pi. Right, so if you go all the way around a circle, you end up with 2 pi. If you go halfway around a circle, right, so halfway is just 1 pi. So a pi is over here. Yeah? Okay, I'm gonna erase that. All right, so if I go half of a half, half of a half, so half way to halfway, just think about it for a second. So I'm gonna end up cutting that in half, right? It's 1/2. This is 1. So this is, we write pi over 2. Interesting. So interesting. Okay, I'm gonna erase this. So just like we did last time, I'm gonna start with like what I know, and then I'm gonna sort of like go from there, and I'm gonna look for patterns, because I'm always looking for patterns. Okay, so I went half of halfway. Now I'm gonna go 3/4. Okay. Here's the thing. It's not clear unless you're thinking of the whole piece. So if I have $2, right? So I know that half is $1. I know half of half, right, is 50 cents. So how much money, like how much do I have if I go 3/4? So like 3/4 of 2. I know, it's $1.50. So with that being said, we're gonna leave the fraction. The other thing that I want you to think about, if this is one chunk of pi over 2, this is one chunk of pi over 2, this is a third chunk of pi over 2. Maybe I like that. So I have 1, 2, 3. So I have 3 pi over 2. You don't usually write, what is that? Pi. We don't usually say 1.5 pi because this has a decimal in it. So leave as a fraction. Isn't that weird? Math is so funny. Okay. And then this is same thing. So this is pi over 2. Oops, I combine those. So if I have 4 pi's over 2, I have 2 pi. Sick. Boom. I know. All right. I'm tempted to leave that, but you could like pause the video and write that down. So I'm going to erase some of this other stuff because I'm going to use my I'm going to use my template. Okay. So for some of this, like normally in class we would have a paper plate and there's different angles and we'd measure it out and you would like count how many there are. But we don't have that luxury right now. And so what I want to do is look at the half angles. So I'm talking about the 45. Yes. Here's my bow tie again. So I'm talking about this. So if I go here, if I have something if I have half, let's call it 50 cents. What's half of this? Divided by 2. Right? So 0.25. So here I'm going to have pi over 4. Okay, so I'm going to use this really cool color, and I'm going to use a highlighter. I think this will work. So from here, I have pi over 4. And then I have another pi over 4. 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 Cool, cool, cool. I'm going to go back here. So this is a pi over 4. Right? These are all pieces that are pi over 4. Pi over 4. Pi over 4. Pi over 4. So I can cut my circle into, well, infinitely many pieces. But you're not going to do that because that'd be too much. So from here, I'm going to like literally count up how many pi over 4s I have. I know. But we only care, I'm going to use the blue. We only care about these ones, the blue ones, right? Now they're like a green. I regret about that. Bon, ça va. Okay. So I have 1 pi over 4. 2, 3. So when I hit this line, I have 3 pi over 4. Because I have 3 of them. I have 1, 2, 3. I know. So I'm going to, that's 3, right? 3. So this is 4. 5. So this is 5 pi over 4. Okay, so this is 5, right? So when I hit, it's kind of hard to see because, here I'll do this. Oula, bon ça va. C'est pas grand chose. Hein? Okay, so when I hit this point, right? So that was 5. 6, right? 6, 7 pi over 4. So when I'm hitting this, I'm at 7 pi over 4. And then here's the thing. If I went again, this is like 8 pi over 4. Which is 2 pi, you guys. Wow. I know. Isn't it so cool? Freaking love it. Okay, so here's the thing. You can do the same with the others. I'm kind of like, oula. I don't want that. I don't want that. Comment je peux faire? Bye. Okay, so I'm going to erase this. So same thing, if you want it, you go back and pause it. I think I'm going to make, actually, now that I'm thinking out loud, I'm going to make different versions of this, because this is what we would do in class. God, I miss having real person class. Makes things a little bit easier. Okay, so I wish I could like smooth this out just a little bit. Oh my gosh, I'm just, you know what? Listen, everything is fine. I'm just going to erase this junk. It's not my best video. It's not my worst, probably. Okay, ça va. Whatever. Okay, so what colors do I have left? Let's do purple, because purple's legit awesome. So I want to focus a little bit on these ones, because 30 and 60 are of the same beast, right? They're multiples, like 30 is included. So, oh gosh. In this quadrant, I have 30 degrees. I have 30 degrees. I have 30 degrees. I'm going to break that up with a pen. So I have 30, 30, 30, right? Because it's 90. 3 gives a 30. Okay, so what I've done is I've cut this into thirds. Yeah? So I'm taking, I have pi over 2, right? That's what I have here. Pi over 2, and I'm cutting it into thirds. Remember when I made you watch the Puffin video with Mr. Ward? You're like, why are we doing this? Because trigonometry. Pi over 6. So each one of these little slivers of like cake or pizza or that one board game that's too hard to play, Trivial Pursuit, each one of these is pi over 6. I know. Mic drop. Much. So I have 1, 2, 3. But then look. Well, I don't really want that. Sorry, you can't see what I'm doing. 1, 2, 3. So 3 pi over 6 is pi over 2. So when I stop here at this one, up to 60, I have 1, 2. I have 2 pi over 6, which is pi over 3. I know, it's magical. So that's how you're going to sort of like chunk it up. The other thing you can do, so like that big angle, right? So like I think about 60 pi over 3. So all the multiples of 60 are going to have like divided by 3. So I'm just going to write the rest, and I'm going to look for the picture where I post it all. But for example, so 120 is related to 60. That's 1. So this is 2 pi over 3, right? Because I would have like a similar size like chunk, like to that chunk. This is 5 pi over 6. Because 6 pi over 6 would be pi, you guys. Yeah, I know, it's amazing. Quadot. This is, so one more would be 7 pi over 6. Here's my multiple though. And so I'm going to have 4 pi thirds. We already have that one. This is 5 pi thirds. So check out where the thirds are. Third, 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 third. They're by the y-axis. Interesting. And then 11 pi over 6. Because, just like this, let me erase this for a second. Ooh, je peux pas. Non, ça va. boom. If I have 12 pi over 6, that's 2 pi. Sick. Okay. Super crazy, super messy. Again, if you can get the first quadrant, if you can get all this stuff in the first quadrant, you can derive the rest. It'll be a little bit of work, but you can do it. The other thing, and I wish you could like see, you can like hear it on my mic, like you'll have a copy of this. And so I know some teachers will like give you a test without a unit circle, but like generally when you're doing advanced math work, like you'll have this will be literally printed in the front of your book, or you literally look it up online. And so at first it's like, okay, can you remember how this works? Can you remember the order? Like the size of the pieces are important, right? So like this, I need to know that this is 30 degrees. But other than that, like you'll have this reference. So this is really overwhelming to you. Like, yeah, I agree, right? Like this is crazy stuff, but stay calm. You'll be okay. And then look for the document that I'll put up, and I'll show each of these breakdown. Okay, that's a long video. Sorry. Bye. Or wait. Crap. I wanted to show conversions. Okay, sorry. I lied. I'm sorry. Sorry. All right, conversions, because this is in the Desmos. Okay, so just like science, you'll have, and this is in the Desmos, like it tells you this. And it even gives you an example. So you'll have these ratios to set up. Ratios to set up your conversions. Like you will have them. Yeah? Okay, so an example. Let's do blue. It says something like this. Like convert to degrees. So same thing, if you have your resource, you have your textbook, you're like, cool, that is 60 degrees. Maybe you have it memorized, I don't know. But if not, you can use the equation. So I want degrees. And this is like the only part of chemistry I could do. So like set up ratio to eliminate. Oh dear, it's been a long day. It's Sunday. Eliminate pi. Okay, so if I have this, I want pi. I'm gonna do blue. I don't think you'll be able to see that though. So let me highlight it with this blue. I want this in the denominator, right? So I want to set up to eliminate. Ooh-la. You didn't see that. Undo. Oh dear. Okay, so I'm going to set up pi, which means I want 180 up here. Okay, so this is why we did rationals, kind of, right? So I can rewrite this. You don't have to. And then, so that's 1. No matter what, right? Pi divided by pi is 1. And then this is 60 degrees. So pi over 3 equals 60 degrees, period. Yeah? Okay, so another example, let's say, because I think you'll have both. Example, you'll have 225 degrees, we'll say. And we'll say convert to radians. Okay, so I want radians. It's good to like say what you want in math, because otherwise, you know, things get complicated. So I have 225 degrees times, I want to cancel out. So I'm going to do my like blue again. I want to cancel this out, right? So eliminate. So that means pi goes up here. Okay, so we're going to leave pi. Remember? I said that a while ago. Pi. So I'm going to like figure out what, oh gosh, I remember this one. Okay, so for me, I divided by 5 first, I believe. Whoa, I didn't know I could do that. So first I'm going to do 5, and then I'm going to do 5 divided by 180. So that is 45, 3, 36. So 45 pi divided by 36. And then 45 and 36 have a 9. So I'm going to like reduce. So that's 5/4 pi. Okay. So 225 degrees is equal to, so it's not a squiggly, it's not this. It's equal to 5 pi over 4. Boom. Done. And this was done up here. Okay. Great. That's the last bit I wanted to show you. You'll practice this. This is good. It's good math because it'll help you with everything. Okay, that's long. I'm sorry. I'm out. Bye.